Hello everyone and welcome to this video on HCF and LCM. In this video we will understand what is HCF, what is LCM and discuss the various methods for finding HCF and LCM. Then we will see how to find the HCF and LCM of a fraction and then we'll solve some problems based on HCF and LCM. So let us first start with HCF. HCF, as we all know, stands for highest common factor. It is also called as the greatest common divisor. So what is this HCF? It is basically the highest number that can divide a given set of numbers. If we consider two simple numbers, let us say 12 and 18. So 1 can divide both these numbers, 2 can divide 12 and 18, even 3 can divide and 6 can divide. So highest among these is 6. 6 is the highest number that can divide both 12 and 18. Hence, 6 is the HCF of 12 and 18. Whereas LCM, it stands for least common multiple. It is basically the smallest number which can be divisible by a given set of numbers. If we consider two simple numbers, let's say 15 and 9. Then the smallest number which can be divisible by both these numbers 15 and 9 is 45. So 45 is basically the LCM of 15 and 9. So this was the basic definition of HCF and LCM. Let us now see how to find HCF and LCM one by one. Starting first with HCF, let us consider this example. Suppose if we were to find the HCF of these three numbers 136, 144 and 168. So there are basically three methods for finding HCF of these numbers. The first method, you will have to write these numbers as a product of their prime factors. So this 136 can be written as 17 into 8, which can further be written as 2 cube into 17. Likewise 144, which is 16 into 9, can be written as 2 raised to 4 into 3 square. 168 can be written as 21 into 8, which is 2 cube into 3 raised to 1 into 7 raised to 1. So HCF by definition is the highest number which can divide all these numbers. So for that we will take the highest number which is common to all these three numbers. So as you can see, 2 cube is common to all these three numbers. 2 cube is there in 136, it is there in 144 and it is there in 168 as well. Whereas 3 is there in 168 and 144. It is not present in 136, hence it cannot be taken. Same way, 17 is only present in 136 and 7 is only present in 168. So the only common factor is 2 cube. Hence 2 cube, whose value is 8, is the HCF of these three numbers. So this is one way where you have to factorize these numbers and you can find the HCF. The second method is based on the principle that if say a number x divides two number n1 and n2, then it should also divide the difference between these two numbers. So by applying this principle, for that we'll have to take the difference between any of these two numbers. Let's say if we take the difference between 136 and 168, 136 and 168, it will be 14 plus 18, that will be 32. So HCF by definition is the number which divides all these three numbers, hence it should also divide the difference between any two numbers. In other words, it should be a factor of 132. That is the difference between any two numbers. So what are the factors of 32? 1 into 32, then 2 into 16, 4 into 8, and then the factors will keep on repeating. So now these are the factors. One among these factors will represent the HCF. So for that we'll have to take each of these numbers one by one, starting from the biggest number, and check whether this number divides all these three numbers or not. The number which divides all these three numbers will be the HCF of these three numbers. So let us start first with the biggest number, which is 32. 32 into 4 is 128, hence it is not going to divide 136. So 32 cannot be the HCF. If we check for 16, 16 into 8 is 128, hence it will not divide 136, hence 16 cannot be the HCF as well. So if we check with 8, 8 into 17 is 136, hence it can divide 136. Then 8 into 18 is 144, hence it will divide 144 as well. Then 8 into 21 is 168. So 8 is the number which can divide all these three numbers, and it is the highest number which can divide all these three numbers. Therefore, the HCF of these numbers will be equal to 8. Same as that we have got by the previous method. Now another method for finding the HCF is you take the greatest number and divide it with one of the smaller number. So in this case, the greatest number is 168, and you can take any one of the smaller number. You can take 136 also or 144. Let's take 144, and you will have to divide. So the remainder that you are going to get, let's say it will be R. Then you will divide this divisor by this remainder. So you will divide 144 by this remainder. Then you will get some other remainder, say R2. Then you will divide R1 with R2. And this process will go on till you get the remainder as 0. The last divisor that you are going to get will be the HCF of 144 and 168. Now there is a third number as well, which is 136. So what you will do is the HCF that you have obtained of 144 and 168, you will compare that HCF and 136. Then you will divide the bigger number by the smaller number and repeat the same procedure till you get the remainder as 0. The last divisor that you are going to get will represent the HCF of all the three numbers. So let us see how it is to be done. So we will take the biggest number, which is 168, and divide it by 144. So 144 ones are is 144. The remainder will be 24. So we will divide 144 by 24. So 24 into 6 will be 144. So here the remainder is coming out to be 0. So this 24 represents the HCF of 144 and 168. And the third number that we have is 136. So out of this 136 and 24, 136 is the bigger number. So we will divide 136 by 24. So 24 into 5 is 120. We have a remainder of 16. Now we will divide 24 by 16. So 16 ones are is 16. The remainder is 8. Now we will divide 16 by 8. So 8 twos are is 16. We are getting a remainder of 0. So the last divisor, which is 8, represents the HCF of all these three numbers. So in this way, by using any of these above three methods, you can find the HCF of a given set of numbers. Out of these, the second and the first method are more practicable, which will help you in saving a lot of time. Now let us see how to calculate the LCM. If we consider the same set of numbers, that is 136, 144 and 168. So again here we have two methods. One is by using the prime factorization method, that is we have to express each of these numbers as a product of the prime factors. As we have found out in HCF, 136 can be written as 2 cube into 17 raised to 1. 144 can be written as 2 raised to 4 into 3 square, and 168 can be written as 2 cube into 3 raised to 1 into 7 raised to 1. So now to find the LCM, by definition LCM is the smallest number which will be divisible by all these three numbers. So for this LCM to be divisible by 136, it should contain at least 2 cube and 1 power of 17. That means it should have 2 cube and 17 raised to 1. It can have more power, but this is the minimum power that we need of 2 and of 17. Now for this LCM to be divisible by 144, it should have a minimum power of 2s4. Then only it will be divisible by 144, and minimum power of 3s square. Now we have taken 2 cube, so we need one more 2, and we need 3 square. We don't have any 3, so we'll multiply it with 3 square. Then for 168, for this LCM to be divisible by 168, it should have a minimum power of 2 cube, which we already have. In fact, we have 2 raised to 4, so that is okay. We should have 3 to the power 1. We have 3 square, so that is also covered. Then we need to have 1 power of 7. So that is not available, so we'll multiply it with 7 also. So if you look at this consolidated powers, we have 2 raised to 4, then 3 square, then 7 raised to 1, then 17 raised to 1. If you notice, these are basically highest power of each of the factors available in all of these three numbers. So the highest power of 2 in all of these numbers is 4. So that's why we have 2 raised to 4. The highest power of 3 in all of these numbers is square. So that's why we have a square here. And the highest power of 7 and 17 is 1 only. So you don't have to really go and check in that way. All you have to do is directly take the highest power of each of these factors and write it down. That will give you the LCM. So it will be straight away 2 raised to 4, 3 square, 7 raised to 1 and 17 raised to 1. If you multiply this, you will get your answer as the LCM of these three numbers. Now another way for finding the LCM is, let us take this set of numbers 5, 25, 125, 300 and 550. In this method, what we will do is we'll conduct simultaneous division of all these numbers. And the product of all the divisors will represent the LCM of these numbers. So first of all, we'll discard 5 and 25 from the list, because any number which is a factor of 125 will also be a factor of 5 and 25, because 5 and 25 themselves are a factor of 125. Hence, we can discard 5 and 25. We can directly take 125 and the other two numbers 300 and 550. So let us start this division. So we'll start with the first prime number, which is 2. This will 125 will remain as it is. We'll get 150 here, and this 550 will become 275. Then further division by 2 is possible. So we'll have 75 here, 275 here, and this 125 will remain as it is. Now we cannot divide it by 2, so we'll go to the next prime number, which is 3. Let's see if any number is divisible by 3. Yes, 75 is divisible by 3. So we'll take 3. This is not divisible, this is not divisible. So here we'll get 25. 125 will remain as it is. 275 will also remain as it is. Now no further division is possible by 3. So we'll take the next prime number, which is 5. So this will become 25. This will become 1. This will be 55. Now again we can divide it by 5. This will become 5, 1, 11. Again by 5, this will become 1, 1 and 11. And then finally we will divide it by 11. So this will become 1, 1, 1. Now since all these further division is not required. Now if you multiply all these divisors, we'll get the LCM of these numbers. So in this case the LCM will be 2. The power is square. Since there are 2 2s, there is only 1 3. There are 3 5s and 11. So if you multiply all these numbers, you will get the LCM of given set. Let us now understand how to calculate the HCF and LCM of a fraction. But before we start, one important point to note here is, for finding the HCF and LCM of a fraction, say a by b, this fraction should be in its lowest form. Like for example, you cannot find HCF and LCM of 15 upon 45. You will first have to reduce this fraction, because we can take 15 common from both the numerator and denominator, and this can be reduced to 1 by 3. So like this way, you will have to first reduce all these fractions to its lowest form, and then you can proceed with this method. So this is the most important point you need to take into account. So the formula for HCF of a fraction is given by HCF of the numerator divided by LCM of the denominator, and LCM of a fraction is given by LCM of the numerator divided by HCF of the denominator. Let us consider one example and understand these formulas. Let's take this set of ratios, 16 upon 20, then 8 upon 35, 2 by 15, 6 by 25. The first thing that you should check is whether all these fractions are in their reduced form or not. So if we start with this one, 6 by 25, yes, it is in its reduced form, hence it is okay. 2 by 15 is also okay. 8 by 35 is also okay. In case of 16 by 20, as you can see, you can take 4 common from both the numerator and denominator, and this can be reduced to 4 by 5. So now we will take these fractions and find the HCF and LCM. It will represent the HCF and LCM of these numbers. So for that, we need to find the HCF of the numerator, then LCM of the denominator, and for HCF of a fraction, we need to find the HCF of numerator and LCM of the denominator. For LCM of a fraction, we need to find the LCM of a numerator and HCF of the denominator. So let us find that. We'll find first the HCF of numerator and then HCF of the denominator. Then we'll find the LCM of the numerator and then LCM of the denominator. The numbers in the numerator are 4, 8, 2 and 6. As we know, HCF is the highest number that can divide all these numbers. So just by visual observation, we can say that 2 is the highest number that can divide all these numbers. So the HCF of the numerator is 2. To find the LCM, we'll have to use simultaneous factorization. Since 2 and 4 are a factor of 8, we can ignore them. So we'll have 8 and 6 here. So 8 is basically 2 cube. So this will become 1. 6 will reduce to 3. So we'll have to divide it by 3 as well. So the LCM of the numerator will be 2 cube into 3, which is 8 into 3, which is 24. So this is the LCM of the numerator. Now the term in the denominators are 5, 15, 35 and 25. Again, just by visual observation, since HCF is the highest number that can divide all these numbers, so the HCF by observation we can say that is 5. For the LCM, we'll have to do simultaneous factorization. Since 5 is a factor of 25, we can ignore 5. We'll take rest of the numbers. First we'll start with 2. None of these numbers are divisible by 2. We can take 3. So this will become 5, 35 and this will remain as 25. Then we can take 5. So this will become 1. This will become 7. This will remain as 5. So we can again divide it by 5. So this will become 5 square. 1, 7, 1. Then we can finally divide it by 7. So this all will become 1. So if the LCM of the denominator will be 3 into 5 square into 7, which is 25 into 3, which is 75. 75 into 7, which will be equal to 5 is 35, 49, 52. So the LCM of the denominator will be 525. So now HCF of the fraction by using the above formula is HCF of the numerator upon LCM of the denominator. So this is 2 upon LCM of the denominator, which is 525. So this is your HCF. For LCM, the formula is LCM of the numerator upon HCF of the denominator. LCM of the numerator is 24 upon HCF of the denominator, which is 5. So this is your answer for HCF and LCM of the given set of fraction. The only important point that you need to consider is that the fractions should be in their reduced form. Let us now solve few problems based on the concepts of HCF and LCM. So let us take this numerical. Find the largest number which one divides 95 and 158, leaves a remainder of 2 and 3 respectively. So basically we need to find a number such that it should completely divide 95 minus 2 and it should completely divide 158 minus 3, because then only when that number divides 95 and 158, it will leave a remainder of 2 and 3. So we need to find a number which can divide both these numbers, 93 and 155, and that too the largest number, which in other words we need to find the HCF of 93 and 155. So by using the method of prime factorization, or you can use the division method, or you can take the difference between any two numbers and find its factors. So if we go by that method, the difference between 155 and 93 is 55 plus 7, that is 62. You can write the factors of 62. It will be 1 into 62, then 2 into 31, and that is it. So these are the 4 factors of 62. We can start checking the divisibility of these two numbers by each of these factors. So clearly these are both odd numbers, hence 62 cannot be the HCF. Let's check with 31. 31 into 3 is 93, hence it is divisible. 31 into 5 is 155, hence this is also divisible. So the HCF of these two numbers are 31. So the answer to this question, the largest number which divides 95 and 158 such that they leave a remainder of 2 and 3 respectively, is 31. Let us take another problem. Find the largest number which when divides 125, 173 and 245 leaves the same remainder. So the answer to this question will be given by HCF of the difference between pair of any two numbers. So if we take, let's say, these two numbers, difference between these two numbers and difference between these two numbers. So 173 minus 125 will give us 48, and 125 and 245 minus 125, and 245 minus 125 is going to give us 120. So we need to find the HCF of 48 and 120. So for that we can use the division method. So we will divide the biggest number by the smallest number. So 48 ones are 2s are is 96. We'll have a remainder of 24. Then we will divide the divisor with the remainder. So we'll divide 48 by 24. It is 2s are 48. Remainder is 0. So the last divisor is the HCF of the number. So the answer to this question is 24. Let us take the next problem. Find the smallest number which when divided by 13 or 7 leaves a remainder of 9 in each case, and it is greater than the remainder itself. So now this problem is based on the concept of LCM. We need to find a number which when divided by 13 and 7 will leave a remainder of 9, and that too the smallest number, and it should be greater than the remainder itself. So it cannot be 9, because 9 when divided by 13 will leave a remainder of 13, will leave a remainder of 9. Likewise, when 9 is divided by 17, it will again leave a remainder of 9. So we need to find a number which is greater than the remainder itself. So for that, we need to first find the LCM of these two numbers, 13 and 17. That will give us the smallest number which is divisible by both 13 and 17. And then we can simply add the remainder to get our answer. So we'll add 9 to it. The LCM of 13 and 17, since both these numbers are prime numbers, hence their LCM will be directly the product of these two numbers. So 13 into 17 will be 170 plus 51, that will be 221. So we'll have to add 9, we'll get 230. So this is our answer for this question. Notice in this case, the remainder when the number is divided by two different divisors is the same. Now in this question, if you notice, the divisors are the same, 13 and 17. We again need to find the smallest number which leaves a remainder of 5 and 9 respectively. Now the remainders are different. When it is divided by 13, it should leave a remainder of 5, and when it is divided by 17, it should leave a remainder of 9. But if you notice, the difference between the divisor and the remainder of these two numbers, pair of numbers, 13 minus 5 is 8, 17 minus 9 is also 8. So in this case, all we have to do is find the LCM of these two numbers and subtract this common difference, which is 8. We'll get our answer. So LCM, as we have found out, of these two numbers was 121, and from that we'll have to subtract 8. So this will be equal to 213. So the answer to this question is 213. In this problem, the divisors are again same, 13 and 17. We again need to find the smallest number, and here the remainders are 6 and 11. Again, the remainders are different, and if you take the difference between the divisor and the remainder, 13 minus 6 will give you 7, 17 minus 11 will give you 6. So again, the difference between the divisor and remainder are also different. In the first case that we have solved, the remainder was common. In the second case, the remainder was different, but the difference between the divisor and remainder was same. But in this case, neither the remainder is common nor the difference between the divisor and remainder is common. So let us see how to handle this problem. So the number that we are trying to find, let's say it is n. It is such that it is when divided by 13, it leaves a remainder of 6. So this number is of the form of 13 k1. It is a multiple of 13 with 6 extra, which is your remainder. And at the same time, it is a multiple of 17 as well. Let's say another constant k2 having 11 extra, which is our remainder. So this number is of the form of 13 k1 plus 6 and 17 k2 plus 11. So we will equate these two equations and try to find out the value of n. So from here we will get 13 k1 is equal to 17 k2 plus 5. Now if you notice, the left hand side is a multiple of 13, so the right hand side should also be a multiple of 13. So we can write this as k1 is equal to 17 k2 plus 5 upon 13, where k1 and k2 are whole numbers. Since the left hand side is a whole number, therefore right hand side should also be a whole number. That means the numerator should be divisible by 13. We can split up this 17 k2 and write it as 13 k2 plus 4 k2 plus 5, the whole divided by 13. Now 13 k2 is divisible by 13. That means 4 k2 plus 5 should also be divisible by 13. So now we'll assume some values of k2 and see for which value of k2 this numbers 4 k2 plus 5 become divisible by 13. So if we take k2 is 0, we'll get 5 by 13. We'll get this value as equal to 5, which is not divisible by 13. So if we take k2 as 1, it will become 4 plus 5, which is 9, again not divisible. If we take k2 as 2, it will become 4 to the 8 plus 5, which is 13. Hence it is divisible by 13. So from here we have found out the value of k2 as 2. Now we can just simply substitute this value of k2 in this equation and we'll get our answer. So this number n, which is the smallest number which when divided by 13 or 17 will leave a remainder of 6 and 11, will be equal to 17 into 2 plus 11, which is 34 plus 11, which is equal to 45. So this is how you can solve this question. Let us take one final example. Find the largest 4-digit number which when divided by 9 or 15 leaves a remainder of 7 in each case. Now we need to find the largest number which when divided by 9 or 15 will leave a common remainder of 7. As we know, the largest 4-digit number is 9,999. So we need to find a number which is less than this number such that when divided by 9 and 15 will leave a remainder of 7. So first of all, what we will do is we will find the smallest number which is completely divisible by 9 and 15. And then we will find the largest 4-digit number which is completely divisible by 9 and 15. Once we get this number, let's say that number is m. To that number, we can simply add the remainder, which is 7, and that will be our answer. So our first goal will be to find the largest 4-digit number which is completely divisible by 9 and 15. So for that, we have to first find the LCM of 9 and 15. Since 9 is 3 square and 15 is 3 into 5. So the LCM of these two numbers will be 3 square into 5, which is 9 into 5, which is 45. So the LCM of these two numbers is 45. Now what we will do is, we will divide this largest 4-digit number by 45. Let's see, 9999 divided by 45. 45 ones are, 2s are, 9 carry, then again 2s are, then again 9 carry, then 2s are. So we have left 9. That means we have 9 extra. So when we divide 9999 by 45, we are getting 9 extra. So if we subtract this 9, we'll get a number which is perfectly divisible by 45. So we'll subtract 9 from this. So we'll get 9990. So this is the largest 4-digit number which is perfectly divisible by 45. Now we want a remainder to as 7. So we'll simply add this remainder 7. We'll get the number as 997. This is the largest 4-digit number which when divided by 9 or 15 will leave a remainder of 7. So this is how you can solve problems based on HCF and LCM. These were just a few examples. In the next video, we will solve more problems based on the concept of HCF and LCM. Thank you.